Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about in LTI system correlation functions of input and output process. This presentation will cover the fundamental concept of the linear system analysis. When the input is a random process, we will explore the importance of cross correlation functions in understanding the relationship between input and output processes. Concept of cross correlation function. Definition. The cross correlation function quantifies the similarity between two random processes as a function of time lag between them. Computation. Cross correlation is calculated by multiplying the values of two processes at different time lag and averaging the result. Interpretation. The cross correlation reveals how the input and output of a linear system are related, providing insight into the system characteristics. Relationship between input and output process. Input process. The input to a linear system is a random process which could be signal, noise or combination of both. System characteristic. The linear system properties such as its impulse response determine how the input process is transformed into the output process. Output process. The output process of the linear system is also a random process and its characteristics are related to the input process and the system properties. Importance of cross correlation in system analysis. System identification. The cross correlation function can be used to estimate the impulse response of a linear system, allowing for its characterization. In noise reduction, cross correlation can help identify and remove unwanted noise components from the output signal, improving signal quality. Performance evaluation. Analyzing the cross correlation function can provide insight into the overall performance and behavior of a linear system. Example of cross correlation calculation. Input process. Consider a random input process x of t and a linear system with a known impulse response h of t. Output process. The output process y of t is the convolution of the input x of t and the system impulse response h of t. The cross correlation calculation. The cross correlation function or xy of tau can be calculated from the input x of t and the output y of t process. Interpretation. The computed cross correlation function provides information about the system characteristics and the relationship between the input and output process. Graphical representation of cross correlation. Peak. The maximum value of the cross correlation function indicates the time lag where the input and output process are most strongly correlated. Width. The width of the cross correlation function provides the information about the system's impulse response and the time delay between the input and output. Symmetry. The symmetry of the cross correlation function can reveal the causal or non-causal nature of the linear system. Interpretation of a cross correlation results. Peak location. The time lag at which the cross correlation function peaks indicates the time delay between the input and output process. Peak magnitude. The magnitude of the peak cross correlation value provides information about the strength of the relationship between the input and output. Function shape. The shape of the cross correlation function can reveal the characteristics of the linear system such as its stability and frequency response. Applications and significance of cross correlation. System identification, estimating the impulse response of linear system. Noise reduction, removing unwanted noise components from the signal. Signal processing, analyzing and processing random signal in various fields. Performance evaluation, assessing the behavior and characteristic of linear system. Thank you.